Hello everyone and welcome to my transistor circuit video where I show you how I went from this to this in only the span of a week. So the first thing I have to know when I'm trying to make a circuit is what type of circuit I want to make. And in our science physics GCSE book, I actually found one of these circuits. I brought it up here on the computer because it's easier to see when I do that. And here we see we have a battery, a bulb, a transistor, and then a thermistor and a 10k ohm resistor and a potential divider. I'm suspecting that the thermistor is probably not going to be exactly around 10 kilo ohms, which is why I'm going to switch this 10 kilo ohm resistor out for a variable resistor so that I can kind of try to fine tune it a bit. So now I've made a first type of idea for what my circuit's going to be. So I found that I needed to have an NPN transistor for this specific type of thermistor circuit, and then I'll have a 6-volt battery here, and then the current will flow, and then it won't be able to go in there, so it'll flow, and then it'll flow through the thermistor, and then when the thermistor has less resistance than the variable resistor, that's like when it's heated up, then I'll go through here, and that'll activate the transistor so that all the current can flow through here, and then, or all the voltage, whatever, can flow through there, and then this light will be on. So now I've found out a few things. So first thing, there are no 6-volt batteries, so I'll use a 9-volt instead, and then because I'm using a stronger battery, I've remade the circuit a bit. Now I'm using what's called an emitter-follower layout, and that means that instead of the LED being here, it's going to be on this side, and then I've also put a bit of a resistor there, also to counter the 9 volts, which are a bit stronger. And then this one's a bit weaker because it doesn't really matter. I think it's only really there so that the transistor doesn't get burnt. Okay, and then I also found out that the thermistor, it starts at about 17 kilo ohms in room temperature, and then when you put your fingers on it or you breathe on it or something, it goes down to about 12 kilo ohms. So then it's pretty good. I found a 30 kilo ohm variable resistor, which fits perfectly with this because then I can just set it to anywhere within this range really, and then try a few different things out pretty easily compared to if I just had to switch in a new resistor each time. In this clip, you see me working on making my circuit on a breadboard with an internal power supply that my dad let me borrow so that I wouldn't have to do my circuit straight away on the normal breadboard, as it's both more difficult and when you're twisting the legs you could end up damaging the pieces. Here the circuit didn't really work and I didn't really know what was wrong, so I decided to tear up the whole circuit and redo it.
Okay, there. Now, okay, that's not what I wanted to happen. Let's see. Let's check with the multimeter over here. Let's check voltage. Okay, and over this light bulb, LED. Whoa. Okay, it looks to be about 4 volts, which means that something isn't doing its job because, oh wait, I guess we can turn this actually. Okay, now we've turned this one. See if there's any difference here. Okay, no, still just above 4. That means there's something wrong. Let's see if I can troubleshoot this. So, oh, I know what it is, okay. So, I think that this resistor is actually meant to go to the base of the transistor.
So basically what I did wrong was that I messed up which components were meant to be connected to which legs of the transistor, so here I'm just redoing that.
Okay, the light's off. Let's see if we can turn this. Okay, now the light's starting to come on. You see that? That means that the potential divider is working. So let's turn it so that the light is just on a tiny bit. Okay, it's on a tiny bit. And now hopefully when I touch the thermistor with my warm fingers, this light, or LED, will start to shine brighter. So let's see if that works. So I'm touching it now, and there it is. It's shining a lot brighter. And then when I take them off, it takes a while to cool down. You see, it starts to go down. I'm not doing anything with my hands. And there, now it's shining a lot weaker. And then I put my finger back on, a lot brighter. That's my circuit. Now I just got to move it on to this breadboard and then solder it. Now I've put all the components onto this breadboard, and I'm going to change the wires out to make them a bit nicer before I actually solder it, but this is just to kind of get a sense for how it looks. Here we have my thing I've been working on a lot.
It's
a lot
really-
of issues.
really good.
With the 30K, I was spinning it, and then I got it to work. So now we're going to cover it up so it's easy to see. And there you see Valentine's putting his finger on it. Okay, take your finger off. And then you see it starts turning off. And there it's
back
off.
on.
And there it's back on. Okay, so now I've redone the wiring to make the circuit look a lot better. And now I'm going to show it working because it still works, even though I switched out all the wires. So here I put the ice on, and the light basically completely turns off. And then when I take the ice off, and I blow on the thermistor, the light turns on.
Now I'm going to talk about how my circuit and thermistors in general affect society. Meanwhile, there's some footage of me soldering in the background. So, what do I think about thermostat circuits like my own? Well, they're used in everything from portable heaters to refrigerators, electric stovetops, hair dryers, and even home heating systems and air conditioning systems. Plus, they're faster than normal mercury thermometers. What's not to love? The only negative I really see is that a lot of them use cobalt, which fuels exploitation of people in a lot of countries in Africa, like the Democratic Republic of the Congo. But it is possible to make thermistors without cobalt, so I think we could just start using that more. And I actually did a thermistor circuit for this reason, because it's so easy to understand how they're used, and they have so many different use cases. Let's say, for example, an AND gate. It might be kind of hard to understand how just making one of those gates can lead to making a whole computer or a whole telephone. But the thermistor, it's actually easy to understand, let's say, how it's used in an air conditioning. When the thermostat feels that it's warm, then it's going to start cooling. And in my opinion, this makes my thermistor circuit more relevant than, say, an AND gate. So now it's time to do some demonstrating of how the circuit actually works. First of all, here we have the circuit. The last photo was kind of blurry, so let's see if this is any better. Okay, let's move the light away. There. So here you see, here's where I connect to the 9 volt. And then you have the positive end going into the transistor. This is what's called an emitter follower setup, which is where the LED is it's on the negative side of the transistor. That's normally worse, but in my case, since I have a 9 volt battery, if I have a 6 volt battery, then because the other way is more energy efficient, then I would put the LED on the other side. But because I have the 9 volt, which is stronger, I need to put it on this side. Okay, and then we have up here, we have first the thermistor here, and then the variable resistor, 30k ohm variable resistor. We have our multimeter here put onto voltage. So let's see here. Or move it a bit away so you see a bit better. So first, I'm going to need to put this on the right setting. So here you see, not very bright. Put my finger on it. A lot brighter. That's the circuit working. So this transistor that I have, it's an NPN transistor. It's a BC547, if I'm not wrong. And I looked this up. So this type of transistor, basically how a transistor works, it's a semiconductor. You need a certain amount of voltage in the base for the collector to let voltage through it out. That goes out through the emitter afterwards. So, and then up here we have the potential divider. And when you have, since the transistor, this specific transistor, you need, if the light would be on this side, the positive side, then you would only need between 5 and 6 volts. No, I mean 0.5 and 0.6 volts for the transistor to be able to go. But because the light is on the further side, the LED, then you actually need over 0.6 volts. So let's measure the transistor. Okay, and look at that, we have 0.5, and we would need 0.6 for the light to be on. So the potential divider up here, basically what it does is that if we chuck this variable resistor, 2 volts going through the variable resistor, 7 volts going through the thermistor. So most of the electricity, most of the potential difference, we're losing it in the thermistor. And that means that not a lot of it is going down through this resistor into the base here of the transistor. See if maybe you see it if I turn it a bit. There's a transistor there in the middle of the black one. Okay, but then when I put my finger on this, wait, I guess I can try to do this. Okay, it's at 7 right now. Put my finger on it. And you see it goes down. It's mirrored, sadly for you, but it's on 6.7 now. And then that means that more potential difference, more voltage is going through this resistor right here into the base of the transistor, which if you remember needed to be at 0.6 volts. And then right now, it's at 0.5. Wait, let's see if I can. 0.5. And there it's at 0.6 and the light's on. I don't know if you see the lights on, but there. Thank you for watching this video. Hope you enjoyed it. Sorry if it's a bit long. If you want the sources, they'll be down in the description. Like, sub, leave a comment if you have any questions. Bye.